Welcome, my dear students, and prep 2. Our session today is about Euclidean theorem. But before we start talking about Euclidean theorem, let's take an exercise about the projection. In this exercise, we have two right-angle triangle, triangle ABC and triangle ACD. The two triangles are right-angle triangle. So the measure of angle DAC equals the measure of angle ACB equals 90 degrees. I want to get the length of the projection of AB on AC and the length of the projection of CD on AD. Okay, so let's begin. I want to get at first the length of the projection of AB on AC. A belongs to AC, so the projection of A is A. Then B on AC, let's see here, this is B and this is AC. I'll draw a perpendicular from B to AC, so it will be intersects AC at point C. So the projection of AB on AC is AC. So the first one, I want to get the length of AC. B, I want to get the length of CD on AD. This is CD and this is AD. D belongs to the straight line AD, so the projection will be D. And now let's get the projection of C on AD. This is C and this is AD. Draw perpendicular to AD, intersects at A. So I want the length of the line segment AD. So I want to calculate the length of the line segment AC and the length of the line segment AD. The length of the line segment AC, I'll calculate it using the Pythagoras theorem. Here we have a right angle triangle ABC. The right angle triangle here is ABC. I have two side lengths. I can get the third using Pythagoras theorem. AC power 2 equals the hypotenuse, the square root of hypotenuse power 2 minus the other side power 2. So it will be square root of 13 power 2 minus 5 power 2. It will be 12 centimeters. Now I want to calculate the length of AD. I have another right angle triangle ADC. I have two side lengths 12 and 15. I want the third, so I can use Pythagoras theorem again. The length of AD equals the square root of hypotenuse power 2 minus the other side power 2. So it will be the square root of 15 power 2 minus 12 power 2, which is 9 centimeters. So now I calculated the two projections. Let's move to Euclidean theorem. We use Euclidean theorem if we have a right angle triangle and from the right angle we draw a perpendicular to the hypotenuse. In this case, I can use Euclidean theorem. Euclidean theorem, the length of any side of the right angle triangle equals to the projection of this side on the hypotenuse multiplied the length of any side of the right angle in a right angle triangle equal power 2. So the square of the length of any side of a right angle triangle equals the product of its projection on the hypotenuse multiplied by the hypotenuse. Okay, how can we apply this on this theorem on this triangle? AB is the first side of a right angle triangle, so AB power 2 equals, what is the projection of AB on the hypotenuse? BD. So AB power 2 equals BD multiplied by all this side, which is the hypotenuse, which is BC. So AB power 2 equals BD multiplied by BC. This is the first right angle side. The second right angle side is AC. Okay, AC power 2 equals what? Equals the projection of AC on the hypotenuse, which is CD, multiplied by the hypotenuse, which is CB. Okay, so now we can calculate the length of any side of a right angle triangle using Euclidean theorem. Now, also by using Euclidean theorem, we can calculate the length of the line segment drawn from the right angle to the hypotenuse by using one of the two rules. The first rule gives AD power 2. AD power 2 equals DB multiplied by DC. This is the first one. Gives the square of the line segment AD. The other rule, AD equals AB multiplied by AC, the two sides of the right angle, divided by the hypotenuse. Okay, so we have two rules. We can use one of them according to the given in the problem. Let's take an exercise. Here we have XYZ is a right angle triangle, and from the right angle we draw XL, which is perpendicular to hypotenuse. So I can use Euclidean theorem here. Number one, I want to calculate the length of XY. What is XY? This is XY. XY is one of the sides of the right angle. So I can calculate it using the rule xy power 2 equals the projection of xy over multiplied by the hypotenuse. The projection of xy is 9 centimeter here, and the hypotenuse is 9 plus 16, which is 25. So to get xy power 2 will be 9 multiplied by 25. 9 is the projection of xy on hypotenuse, 25 is the length of hypotenuse. It will be 225. To get xy only, I'll take the square root of 225. It will be 15 centimeters. Number 2, I want the length of xz. By the same way, xz is one side of the right angle, so the length of xz power 2 equals the projection of xz on hypotenuse multiplied by the hypotenuse. So 2xy xz power 2 equals 16 multiplied by 25. It will be 400. Then I'll take the square root to get xz. It will be 20 centimeters. Finally, I want to get the length of xl. xl drawn perpendicular to the hypotenuse. So I can get the length of xl by two ways. xl power 2 equals 9 multiplied 16. This is the first way. xl power 2 equals 9 multiplied 16 equals 12 centimeters. Also, I can use the other rule, that xl equals xy multiplied by xz over zy. I'll get the same answer in the two methods. Okay, so today we studied Euclidean's theorem, and we use it to get the length of the two sides of the right angle in a right angle triangle. I hope you have understand our session today. Next session we will learn how to classify triangles according to their angles if you know their side length. Okay, thank you very much for watching. See you next session, and goodbye.